in today's lesson, we're going to go over one implementation of linked lists, and we're going to store a Fibonacci sequence inside of the linked list. So to start, the code that is enclosed with this video lesson, we're just going over that right now. So if you're wondering where that is, it's enclosed where you clicked on the video lesson. It should be right under that. So we start by creating an object. So we create a struct of a node object. This is going to be called fib node. And the node has a piece of data associated with it, and it has a link to the next node. And so if we wanted to look at a picture, let me see if I can pull one of those up. Yeah. So this is the picture. Oh, hang on 1 second. It's being a little bit slow. Sorry. And now we're okay. I hope you can see that, but it's basically a list with an item, a piece of data here, and a link to a pointer to the next node on the other side. And so in this example, we have a singly linked list. And then at the very end, the final pointer points to null. So it says null pointer here. I wonder if I can make this bigger so you can see a little better. Yeah, okay. That's a lot better. So hopefully you can see this a little bit better. This is from the book. This is chapter 4, linked implementations. And it's pretty helpful. If you guys want to read the chapter, I highly recommend that you do so. And if you have any questions, just I'm always here to answer them. But anyway, so again, linked list, piece of data, pointer to the next node, piece of data, pointer to the next node, etc., until you get to the last node in the linked list, and that pointer points to null. Okay, so we're going to go back to AutoDraw, and we're going to go back to our code. So that's what one of these will look like. We'll use that representation, that little square box representation, when we make new nodes and join them together. So the first thing we want to do is ask the user how many Fibonacci numbers they want to see. And this code is going to output, if they want to see 5 Fibonacci numbers, it's going to output 5 Fibonacci numbers, the first 5 in the sequence. And if they want to see 10, it's going to show the first 10 in the sequence. And let me see if I can get the pen too. Hello, pen, where are you? 1 second. Just 1 second. Let me get this thing to go. Okay. All right. So the way Fibonacci works is f of n equals f of n plus 1 plus f of n plus 2. And these, I know they look like keys, but they're the way I write f's. It's a handwritten f. So we'd start with 1, and then we'd say 1 plus 1, and then 1 plus 1 is 2. And then we'd start doing it like this. So 1 plus 1 is 2, plus 1 is 3, and then 2 plus 3, that's 5, and so on and so forth, and it keeps going. So this is the formula that you used. If you have any questions about this, there's probably better explanations of it than how I'm doing it. I'm just assuming you already know how to do a Fibonacci sequence, but I can go over that with you if you need to meet me via Zoom, or if you wanted to find if you found questions that you have about my explanation. Anyway, I don't want to take up too much time on that part, but we have a setup of initial nodes, and I want to draw out what this looks like. So after we get the user number, we have a line that says fib node head is fib node. So what this is doing is it's actually creating a new node. So we're saying we want to make head of type fib node, and we want it to be a new node. And then in the next line, we make this first node, we make the first node the head. So I'm going to draw one up here. So in the next line where we have, I hope you can see it, first node is head. That's what's happening here. So, and then next we have to create another node. So we're going to make another one. And notice how right now they're not joined together. So that line, fib second fib node is a new fib node. We just need another node. And then here's the linking process. So the first fib node arrow link, it's going to be the second fib node. So that's the part that does this. So that line is the line that does that part. And then second fib node link is null pointer does this part. Null. Yeah, and notice how I'm not writing the word null pointer because the pointer isn't pointing to null pointer, it's pointing to null. This null pointer part is just the syntax that we use with C++. So we're pointing to null, this part. And then we impart our first fib node with 1 and the second with 1. So in the data section, we put 1 here. And then in the next line, we put, oh, I hope you can see this. Oh, there's a 1 here. Oh, goodness. Let me see if I can make this clearer. I'm going to press pause so you don't have to waste your time while I fix it. So just 1 second. Okay, so now I recreated the nodes and they look a lot neater than they did before. So now you can tell they're both storing ones. So that concludes this portion of the code. So if you have any questions about that, please let me know. But if you understand that, then it's time to move on. And this is the part of the code that contains the loop because we want the user to determine, to tell to us how many Fibonacci numbers they want to see. So for however many numbers they want to see, that's how many times we're going to loop through the code. So I'm going to move this a little bit closer here. So for I is 0, I less than the user num, increase I by 1, our output is going to be the output and then toString first fib node, whatever's stored inside the first Fibonacci node, plus a comma. So this toString is part of the string library, and that's why we created the string output here so that we can use the string library. I wanted to also mention that in this code, we actually put the names of the declarations right before where they're used. So you'll notice that usernum is declared right before where it's used. All of these don't really count, that's just a setup. But then output is being declared right before where it's being used. And this is pretty good convention. It's helpful to put the variables right before you use them, and you can group them together in that way. So you don't have to just put all the declarations at the very top. Once you get to a higher level programming, then I recommend that you begin to put the names, the declarations of your variables before where you're going to use them. And that's a nice way to make some clean code. And you're not really going to be taught too much clean code and like how to make code look pretty. So this is me trying to impart some of what I know onto you. And that should help to make your code cleaner and prettier and easier to read. Okay. So, like I said, output, toString, whatever's inside of the first node, we want that and then a comma because we're going to display the first Fibonacci number, comma, the second Fibonacci number, comma, the third, etc., so on and so forth. Okay, now we're going to get back to drawing. So we're going to say the next Fibonacci number is whatever is stored inside of the first node plus whatever is stored inside the second. And in our example, we have a 1 stored inside of the first, and when we put the 2 up here for the second. So whatever's inside this part, which is a 1, plus whatever's inside this part, which is a 2. And this is going to be the next fib number. Next fib number. That's what that is. And then, so now we've stored our next fib number. So what we want to do next is we want to create, or we want to link to a new fib node. So we're looking at this line right here. So what this is pointing to, we want it to point to, and then let me see if I can move this. Okay, hopefully you can still see that. And then we're making a new fib node. I don't like that. I want it to touch, but I don't want it to, yeah, that's a little better. Okay, and since it's a new fib node, it has a part for the data and it has a part for the pointer. So that's what we're doing in that line, okay? And we're taking the second fib node's link and we're establishing that to the new fib node. Then we take the second fib node and we set it equal to what it's pointing to. So here we go. Let me draw that one out for you. Okay, and that step looks like this. So I'm going to take this off and I'm going to make this the second one now. And then, so that's what that step does. Then we point to null. We point this to null. I know I'm trying to do this in a confined space, but I like having the code right next to the pictures. And I hope you like that too. So that's what's happening in this latest iteration, this latest line of code. Then finally, our second item is now the next fib number. So the second node, whatever its item is the next fib number. So in this case, it's going to be, so we have 1 plus 1, and now it's going to be the second fib now has 1. Okay, and then finally, the first fib node is going to be whatever the first fib node is linked to. So let me go ahead and do this step. And now this is 1. Okay. So that's basically it. So let me look for the part where we next fib num. Second fib num. Item is next fib num. There we go. I almost forgot to put this part. This part right here. And that's this part right here where I put the 2. And then it's going to continue. So you can imagine that these steps loop until you reach the end. And then when we reach the end, when we have done this for however many times the user wanted to see the fib nums, we have an output and we have a string function erase where erase, that was crazy. We're erasing the last two spaces, so the comma space at the end, because it's going to show 1, and then the next big number, comma, and the next big number. And the last one, we don't want to have a comma space afterwards. We just want it to be by itself. So we're going to erase the last 2 spaces after that. And then we output the output. And then we manage our data. We manage our linked list and delete all of we delete it so that there's no dangling pointers, that there's no that there's not something that's just utilizing memory that's not doing anything. So we take, while we're not the null pointer, so while the head is not pointing to null, we want to auto next node pointer head points to link, delete head. Head is now the next node pointer, and then it continues. So this auto is a way to tell the compiler to infer what the type is based on the context clues. So in this case, we already know that next node pointer is of type node pointer, and auto is going to determine that at compile time. I hope that makes sense. And I hope all of this makes sense, actually. If this video helps you understand what's happening, then that's good. But if it doesn't, I need to know that so that I can refine these videos until they're helpful in doing what they need to do, which is to teach you what is going on with the code. So that concludes this video lesson. But if you have any questions, let me know. And if this was not helpful, please let me know so I can make a new video and I'll upload that as soon as I can. Okay? All right. So thank you so much for listening and have a wonderful day.